What if I told you that the programming language you're using right now could be silently killing your development speed? Or even worse, setting your project up for disaster? Today, we're settling the debate that's dividing developers worldwide: TypeScript versus JavaScript. And the answer isn't what most tutorials are telling you. But before we dive in, smash that like button and subscribe for more tech insights. JavaScript has been the backbone of web development for decades, while TypeScript, its strongly typed superset, has been rapidly gaining adoption, especially in enterprise environments. But which one deserves a place in your tech stack? Let's dive in. JavaScript was born in 1995, initially conceived as a simple scripting language to add interactivity to web pages. Fast forward to today, and it powers everything from simple websites to complex full-stack applications. Its flexibility, universal browser support, and massive ecosystem have made it the undisputed king of web development. Enter TypeScript, developed by Microsoft and released in 2012. TypeScript isn't a replacement for JavaScript. It's actually a superset, meaning any valid JavaScript code is also valid TypeScript code. What sets it apart is its static typing system, which allows developers to define variable types during development rather than at runtime. That seemingly small difference has massive implications for how we build software. Let's start with JavaScript's strengths. It's dynamically typed, which means variables can change types during execution. This flexibility allows for rapid development and prototyping. There's no compilation step. Your code runs directly in the browser or Node.js environment, making the feedback loop lightning fast. JavaScript's ecosystem is unmatched, with over 1.5 million packages on NPM. Whether you need a routing solution, state management, or advanced animation libraries, there's probably several options ready to plug into your project. But this flexibility comes at a cost. Without type checking, errors that would be caught during compilation in other languages only surface at runtime, often when users are already interacting with your application. As codebases grow, tracking these dynamic types becomes increasingly difficult, leading to what developers call type chaos. This is where TypeScript shines. By adding static typing, TypeScript can catch errors before your code ever runs. The TypeScript compiler analyzes your code and flags type-related issues during development. This leads to more stable applications and significantly reduces debugging time. Let me show you a practical example. JavaScript, OSHA JavaScript version function, calculate total, items. Return items, reduce, total, item, or total plus item price, 0. OSH, this would cause a runtime error if an item doesn't have a price property. Calculate total, price, 10, cost, 15. TypeScript version interface item. Price, number, function. Calculate total, items, item. Number, return items. Reduce, total, item. Total plus item, price, 0. TypeScript would catch this error during development. Calculates total, price, 10, cost, 20, 15. See what happened? In JavaScript, we'd only discover this error when a user encounters it. With TypeScript, we get an immediate warning that one of our items is missing the required price property. This kind of early error detection becomes increasingly valuable as your codebase grows. TypeScript also offers superior tooling support. IntelliSense features in modern IDEs can provide intelligent code completion, highlighting errors in real time and making refactoring safer and easier. This tooling advantage translates to measurable productivity gains, especially for larger teams. But TypeScript isn't without drawbacks. There's a learning curve, especially for developers unfamiliar with static typing concepts. The compilation step adds complexity to your build process. And for small projects, these additional layers might feel like overkill. So how do you decide which to use? Let's create a practical framework. Choose TypeScript. When you're building large-scale applications with long-term maintenance needs, you work in a team environment where clear API contracts are crucial. Your project requires high reliability with minimal runtime errors. You're using frameworks like Angular or Nest.js that are built with TypeScript. Your team has experience with statically typed languages. Choose JavaScript when you're building small projects or rapid prototypes. Speed of development is your top priority. You're working with a legacy JavaScript codebase. Your team consists exclusively of JavaScript developers with no TypeScript experience. You're creating simple front-end scripts where TypeScript setup would be excessive. Here's what the data tells us. TypeScript adoption has grown exponentially in recent years, especially in enterprise environments. According to the State of JS survey, developer satisfaction with TypeScript stands at over 90%, one of the highest satisfaction rates among programming languages. Companies like Airbnb, Google, and Microsoft have all embraced TypeScript for critical projects, citing improved code quality and developer productivity. If you have an existing JavaScript project and want to explore TypeScript, you don't need to rewrite everything at once. TypeScript allows for gradual adoption. Start by simply renaming .js files to .ts and addressing errors as they appear. Use the any type as a temporary solution for complex areas, then gradually add more specific type definitions over time. Beyond just static typing, there are several TypeScript features that even experienced developers might not be fully utilizing. Union types allow a variable to be one of several types. Intersection types let you combine multiple types into one, type guards. Provide runtime checks that narrow down types. The asconst assertion creates deeply immutable objects. Mapped types generate new types based on existing ones. These advanced features can dramatically improve code quality when used appropriately. Looking ahead, both languages will continue to evolve. ECMAScript proposals regularly bring JavaScript new features, many of which TypeScript then adopts with added type safety. The boundary between these languages continues to blur, with JavaScript runtime environments beginning to implement optional type checking. Understanding the strengths of both languages positions you to adapt as the ecosystem evolves. Here's something that might surprise you. At runtime, TypeScript and JavaScript perform nearly identically. That's because TypeScript compiles down to JavaScript, and all those type annotations you write are completely removed during the compilation process. This means you get all the development benefits of TypeScript with no performance penalty in production. The bottom line? TypeScript isn't inherently better than JavaScript. It's a tool optimized for specific scenarios. For enterprise applications where maintainability and reliability are paramount, TypeScript offers substantial benefits. For smaller projects where development speed is critical, JavaScript's simplicity remains appealing. So which language does your team use? And what has your experience been? Drop your thoughts in the comments below. If you found this video informative, please give it a thumbs up and subscribe to STALLYONS Technologies for more insights into the world of tech.